What's up, fellas? Today we're going to be working on Piecewise Functions 14.3. We did these last year, just revisiting some stuff. So, this one says, a parking garage company charges by the hour or any part of the hour. This is actually how parking garages work, just so you know. The sign shows the cost for each hour. Graph a function that will show how much it costs for a customer to park at the garage for X hours. How much will it cost to park for 4 hours and 35 minutes? So for the first hour, it costs $5. And then for each additional hour, or part of an hour, it costs $2.50. That means if you go and park in the garage for 1 hour, you will spend $5. But if you park for 1 hour and 2 minutes, you are charged another $2.50. So you don't actually have to wait the whole hour. They charge you $2.50 right away. So what we can do with this is move this up a little bit, maybe. Okay. You can start kind of by making a table if you are having a hard time visualizing this. So I'm going to say X, Y. X is the number of hours, because that is our independent variable. Y is going to be the money, because that is dependent. Okay, so you can have 0 hours. You could have, it obviously costs $0 if it's 0 hours. But for your first hour, or maybe only for a half hour, it costs $5. And if you only go for 1 hour, it costs $5 still. But what if you go for 1.5 hours? Okay, well then it jumps up to $7.50 because it adds on $2.50. And then 2 hours, still $7.50. When you get up to 3 hours, or even 2.5 hours, it jumps up to $10. If you get to 3 hours, it's still $10. But once you get to 3 hours and 1 minute, I know that's not the same as what I just wrote, but same idea, it goes up to $12.50. And so on. So the graph of this would look something like this. So let's just go up by fives. 5, 10, 15. 1, 2, 3, 4, 5 hours. So the way we draw this is actually what we call a step function. So 0, 0 starts there. We don't really need to plot that, but as soon as you enter the garage, it costs $5. So we're going to put an actual open circle right there at $5, which represents that it's not actually touching that point, but it's approaching that. So at 0 hours, we're going to go up to 5 with an open circle, and it stays at 5 until you hit that first hour, or you get past the first hour. So we put a closed circle here. After you get past that first hour, it jumps up to $7.50. So we put an open circle there, closed circle there, then it jumps up to $10 until you hit 3 hours. Then it jumps up to $12.50 until you hit 4 hours, then 15. So we call this a step function because it looks like steps. So basically this is when you have the same amount for an interval. So in this case our intervals are intervals of 1 hour, and the cost remains the same for that interval. But we do have to use the open and close circles because of the vertical line test. If I put a vertical line right there and they were both closed circles, it would not be a function because it would hit twice. So one of them has to be open, the other one has to be closed. And in this case the left side is open because that part doesn't actually count for your part of the hour. It ends at 1, it doesn't start at 1. Okay, so that's what a step function looks like. It's also a piecewise function. This says a piecewise function is defined by different rules for different intervals in the function's domain. To write a piecewise function, list each rule along with the part of the domain that uses the rule. So in this case, we have 2 pieces. We have this piece and this piece, which means we're going to have 2 different rules. So for the first one, it says f of x equals 2x minus 2 when x is greater than or equal to 2. Now when it says equal to, that's when you put your closed circle. So we're talking about this one right here. And 1/2 x minus 1 when x is less than 2. So when x is less than 2, so everything over here, we're going to graph this function. But everything to the right of 2, we're using this function. That's what a piecewise function looks like, and I will show you how to graph those next, I think. Yeah, okay. So last year we did piecewise functions, just pure linear piecewise functions. Now that we know how to do quadratics, we're going to use a linear and quadratic for this. Maybe. Alright, so I've got my graph set up. The first thing you're going to do with a piecewise function is you're going to look at the top, and you have to figure out what your domain is. So this one says for x is greater than 0. So that means for everything, basically everything positive, you're going to use 3x. So the first thing you do is you plug in your boundary point, which in this case is 0. So even though it doesn't equal 0, we're going to plug in 0, and we're going to use an open circle for that. So when we plug in 0 for x, we get 3 times 0, which is 0. So we put an open circle there. And then you can plug in, because this is linear, you just need one more point, you can plug in anything that's greater than 0. So if you plug in 1, 3 times 1 is 3, so we go over to 1, up to 3. That can be a closed circle because it is greater than 0. And then we know this is linear, so it just goes up in a straight line direction. But then we have the second piece down here, which is quadratic. So we know this is going to be a parabola shaped. And same thing, we still need to plug in the boundary point to 0. So if we plug in 0, 0 squared minus 1 is negative 1. That can be a closed circle because it is equal to 0. So 0, negative 1, we have this, and notice it is still going to pass the vertical line test because we have an open and a closed circle. And then if we plug in anything, we're going to actually have to plug in more points because this is not a straight line. So if we plug in negative 1, we get negative 1 squared, because anything less than 0, because x is less than 0 here. But if we plug in negative 1, we get negative 1 squared minus 1, so that's 1 minus 1 is 0. So that's this point. Plug in negative 2, we get 4 minus 1, which is 3, so back 2, up 3. So we get this like half of a U shape, like so. And that would be your piecewise function. Okay. Okay, next. Whoops. This one wants you to write the function given the graph. So notice this has 3 different pieces. They are all linear though, so that's convenient. So I am going to start from left to right. So your piecewise functions typically look like this. F of x equals, and then they have this curly brace thing. And then your first function here is going to go left to right, so we're looking at this piece right there. Before I figure out what the function is, I'm going to find the domain. So this one breaks at negative 2. So for the one on the left, I'm going to say x is less than negative 2. Notice there's no open or closed circles here, so you actually get to pick whether it's open or closed. If I leave this one open, that just means I have to close the next one. So for the next one, it goes from negative 2 to positive 0, actually positive 0, just 0. So we're going to go from negative 2 is less than x is less than 0. But remember, I didn't put an equal sign there, so this one has to be equal. That way they overlap each other and fill each other in. They can't both be open and they can't both be closed. I mean, they could both be open, but not in this case because there's no hole in the graph. But they can't both be closed or else it would be not a function. Okay, and then the last one goes from 0, remember we're just talking about the x's, to infinity. So we say x is greater than or equal to 0. That way we have an equal on there. Okay, now we just need to figure out what the equations for these are. So for this one, I can see that it's crossing here and here, so that gives me a slope of up 2 over 1. So this is going to be 2x plus something. And if I continue to go up 2 over 1, that might be the best thing to do at this point. Up 2 over 1, up 2 over 1. I will be at, what's that, 2, 3, 4, 5, 6. Would that work? If I plug in negative 3 times 2 is negative 6 plus 6 is 0, as that works. Okay, so that's the first one. The second one, I can see that my slope is going down 2 over 1, so it's going to be negative 2x. And this one you can actually see the y-intercept, it's at negative 2, so negative 2x minus 2. And the last one, it goes, this one is rising 3, run 1, so 3x. Crosses the y-axis at negative 2, so minus 2. So that would be your piecewise function that represents this graph.